welcome back. I sort of took his attempt at counting down, and we were thankfully not distracted by the, woo! Hi, we're back, and we're recording. Come on in. Hi, we're recording. Come on in, have a seat, join us. We're writing on the graph paper today, and it's part of these notes 8-3. This section in your textbook, which is chapter 8, section 3, is going to be broken into 3 different sections over 3 different days. So you're going to see 8-3A, tomorrow will be 8-3B, and then Thursday will be 8-3C. Thankfully, there's only 2 sets of notes, which means day 3 will be a full work day for you. You're welcome. And it's just going to follow through this. The great thing is that you already know most of what you need for this, which is Pythagorean theorem. Let's get into this. So we're going to talk about special right triangles. And the first special right triangle we're going to look at is the square. It's going to come from a square. So I'd like you on your graph paper to draw a square. And we're going to make it 1 unit by 1 unit. So little bitty tiny square. 1 unit by 1 unit. If I draw a diagonal, which is a line corner to corner, I end up with a right triangle with congruent angles here and here. Those angles are 45 degrees each, which makes this a 45, 45, 90 right triangle. Yeah, anywhere you want. Okay, 45, 45, 90. That's how you'll typically see this thing written. Okay, 45, 45, 90. Now, if I wanted to figure out the measure of that side C, the hypotenuse, I would need to hit the Pythagorean theorem. Okay, so let's do it. No calculators, please. No decimals, please. All right, Pythagorean theorem says a squared plus b squared equals c squared. A is 1, b is 1. I don't know what c is yet. I'm going to calculate it. All right, 1 squared is, so then I have 1 plus 1 equals c squared. So 1 plus 1 is 2, and c squared is 2. But I don't want c squared, I want c. A few of you made this mistake on 8-2's assignment, yesterday's assignment. I started grading a few. You forgot to take the square root here. In order to get rid of that square power, I have to take the square root. So I'm going to take the square root of both sides. And c equals the square root of 2, which I have to leave like that, because I can't think of a whole number that if I multiply to itself gives me 2. Because 1 times 1 is 1, and 2 times 2 is 4. I can't get to 2. So I have to just leave it that way. Okay, great, fantastic. But I promise you there's a shortcut here, because there's a pattern, because this is a special triangle. So to find the pattern, let's do it again with a different starting square of a different size. How big should we make this one?
4 by 4.
4 by 4? Okay. 1, 2, 3, 4. 2, 3, 4. I think I'm going to have to zoom out now, huh?
4 by 4?
Yeah, 4 by 4. Okay. So this side is 4, this side is 4, and I'm going to draw my diagonal, which is a hypotenuse of measure C. These are 45 right here, because I started with a square and I cut the square on the diagonal, and that cuts those 90-degree corners in half.
In the middle C, right?
And the middle is C, hypotenuse C, yes. All right, back to Pythagorean theorem. A squared plus b squared equals c squared. A and b this time are 4 each. 4 squared is 16. And 16 plus 16 is 32. Again, to clear the square power, I have to take the square root. Once again, no calculator, no decimal. So I've got to simplify this thing by hand. All right, let's remember how to do this, because we did this a little bit when we were doing distance formula. We did it again when we started playing with the Pythagorean theorem back when triangles first started showing up for us. Okay? So what I'm going to do to figure out what the square root of 32 is I'm going to list out factors. So I want two numbers that multiply together to give me 32. Well, I know 32 is an even number, right? Okay, so I can divide it by 2. So 2 times what is 32? 16. All right, let's break 16 up into some factors. 16 is what times what?
2 times 8.
2 times 8, all right. Oh, I can keep going with 8, can't I? Okay. 8 is 4 and 2. I'm going to write it as 2 and 4 just to keep all the 2's together. And then I can break the 4 up. So 2 and 2 and 2. And then the 4 is 2 and 2. Okay? And I just carried down the factors that I wasn't using. We okay with that? Okay. So now, in order to handle this square root, the square root is like playing a game of Go Fish. It's looking for pairs of numbers. Okay, so let's find some pairs. I have a pair of 2's here, and I have a pair of 2's here, which smudged my ink very badly. I have 2 pairs of 2's, so I'm going to say that I have those on the outside. The one that I didn't have a match for stays in my hand. It stays in the square root. And then the 2 pairs of 2's that I have outside get to multiply together. And so my final result of square root of 32 is 4 square roots of 2. Whoa, this one has a square root 2 also. The first one we did. First one we had a square root 2. This one we did had a square root 2. Do you think all of them are going to have a square root 2?
Yes.
Yes. Do you want to try one more just to confirm it?
5.
Yes.
Okay, 5. They need to be the same.
Oh, 5.
So we're going to do a 5 by 5. All right. Do you guys really want to draw the square?
Well,
Yes? Okay, if you want to draw it, you can. If you don't, you don't have to. I'm going to just draw it ugly, okay? So there's my 5 by 5. Pretend
pretend what?
that I drew it 5 by 5 even though I really didn't.
Oh.
Okay. So there's my square 5 by 5, okay? Drawn really ugly. You okay? So, it's okay.
My C is 5 by 5. Yeah.
Sort of, not really. Okay, so I have my Pythagorean theorem again. I promise this sets you up for a shortcut and then you don't have to do Pythagorean theorem as long as you have a triangle that's set up like this. Half of a square. Okay, 45, 45, 90 triangle. Okay. 5 squared plus 5 squared equals c squared. This is 25. I've got a 25 here. So this is 50. So square root of 50 is c.
It's still 4 by 4, right?
It's 5 by 5.
5 by 5.
Yeah, I changed it to a 5 by 5.
I didn't start, I was like,
Yeah, this one is drawn not to scale this time. I just kind of YOLO shape. Done. All right, so let's find some factors for 50.
start with 5 times 10.
Okay, 5 times 10. Bring the 5 down and let's do the 10.
2 times 5.
2 times 5,
5 times.
or 5 times 2. Here's my pair of 5s. I now get a point in my Go Fish game. That is on the outside. What's left in my hand is on the inside. Square root 2 again.
Is it possible to get one with no square roots?
Great question. I'll answer that in just a moment. What seems to be the pattern? They all have square root 2. What does it look like I did with the leg length to get to this hypotenuse over here.
Right.
What does it look like I did?
Right in here.
Yes, but if I ignore this, if I look at just the numbers.
Oh.
Yeah, it looks like I took the leg length, this is exactly what you were thinking, and I just wrote the square root of 2 next to it. I multiplied by the square root of 2. That's it. That's the pattern. If you start with a leg and you're going toward the hypotenuse, you're going to multiply by the square root 2. That's it. I swear to you, that's all it is.
There's a. How come the first one didn't have a?
Ah, great question. See, this one doesn't have, but what was the leg length?
What one?
1.
Very short.
1 times the square root of 2 is still the square root of 2. So I didn't have to write the 1. All right, let's come over and let's look at number 1 on our examples. We're given a leg length, yes?
We're done with the notes? Like this?
For the moment, we're going to come back to it. Okay, so I have a leg length of 8, yes? What would be my hypotenuse?
8 squared.
8
It's 8.
times the square root of 2. That's it, you're done.
Why what? Why how what?
That's it, because that's the pattern. The pattern says take the leg length
Oh wait, that's stupid.
and multiply by the square root of 2. Yeah. And it's stupid easy, to make it complicated and mess it all up. Don't make it complicated. Don't mess it all up. Just grab the leg length and multiply by square root 2.
It's too much numbers.
That's why. This is the reason why the pattern works.
So no matter what, it's always gonna be 2.
Always. For a triangle that is 45, 45, 90 degrees on the angles.
Okay.
If the right angle is anything else, this does
Number
not
2
work.
would be the same thing.
Okay? All right, I want to show you another, but what if, okay? YOLO some triangle, okay? Back in our notes. We're going to set it up, pretend it's a square. I know it doesn't look it, okay? It's just drawn whatever. What if our leg length was 3 times the square root of 2? There's already a square root of 2 there. And I want to know what is the hypotenuse.
So
What's the pattern?
It's 2, 3.
Take this number and multiply it by the square root of 2. Okay, boss. 3 square root of 2 times square root of 2. When I have 2 square roots of 2 hanging out like that next to each other with multiplication, I can rewrite it as 1 square root and the stuff inside multiplied together. Okay? It's like I had in my Go Fish hand a 3 and a square root 2, and I drew from the deck another square root 2 and I put it in my hand. Right? So I stuck them together in my hand. Oh, look, now I have a pair, yes? That 3 hangs out. This pair comes out of the square root. And now I have 3 times 2 is 6. The pattern stayed the same. I still multiplied by square root 2.
306.
So my answer is 6 for this one. Square root 2 disappeared, but because it basically filled up the pair that I needed in the square root. Okay? Easy enough? Mm-hmm. Good. Find another clean spot in your notes graph paper thing. All right, what if I give you some right triangle, and I'm telling you that these sides are, these angles, are congruent. And instead of giving you a leg length, this time, I give you the hypotenuse. And I give you the hypotenuse this way. And I ask, what's the leg length?
Would it be 80?
Okay, I'm hearing 6 square root of 2. I'm hearing sounding like the start of the Pythagorean theorem. If I look back at my original pattern, it went leg to
Don't you get-
hypotenuse
oh.
multiplied by square root 2. So I'm trying to undo a multiply by square root 2. How do you undo multiplication?
Right.
Division. So divide by square root 2. Right? You panicking right now? Relax, let me show you how to do it. This is going to be easy. Okay, check this out. So you're okay if I write that division this way, yes? 6 divided by square root 2, are you okay with that? Yes? Okay, cool. Now to handle this kind of, oh my god, I have a square root in the bottom of my fraction, we're going to multiply by another fraction. But it's a special fraction. It's a fraction that is really just a funky way of writing the number 1. We're going to fill up that pair that's in the bottom of the denominator, the bottom of the fraction. What I multiply to the bottom, I have to multiply to the top so that it stays 1. And now I'm going to multiply straight across. I'm going to use this argument from over here to say that's 2. Tell me if you're okay with that. Or if you have a question how I went from here to here. The answer is here. Give me a nod or a thumbs up when that makes sense and I can move on. Okay,
How's it?
Okay. Right here. It's right here.
Oh, yeah.
Okay, we're figuring out how I went to the 2. Just give me like a quick nod or a thumbs up when you get how we got to the 2. I'm just going to keep making quick eye contact with just about everyone. Okay. This is 6 divided by 2, isn't it?
Yes.
Yeah. Which is a 3 up here. So this then is 3 square roots of 2.
That's the answer.
Yes. Here's the shortcut to this pattern. Okay? Take this number, whatever it is, divide it by 2. Whatever answer you get, multiply it by square root 2. That's it, that's the pattern. It's a little more complicated than the other one, but not by much. Take the number on the hypotenuse, divide it by 2, then multiply square root 2 to it. Okay? Look at number 3 on the pre-made notes I made you. Are you given a leg or a hypotenuse? Hypotenuse. What was the pattern?
That's the, what,
Divide by 2.
That's that?
Divided by 2. And that gives you
9.
9.
Square root 2.
And then you tack on a square root 2 to it, and that is the measure of the leg.
Okay, so 18. It's always divided by 2, right?
Always divided by 2. This is the pattern. This is the recipe. It's like the way you make toast. Get bread, stick in toaster, push thing down, wait. Like that's the recipe. That's how you make toast. Right? This is the recipe. This is how you make special right triangles. 45, 45, 90. That's it. That's all there is to it. Do you want to see what happens if this is an odd number?
Yeah.
Yes? All right. So if it's an odd number, give me an odd number.
7.
7. I love it. Whoops. 7. The pattern was what? Divide by 2. So now I have 7 divided by 2. I'm not going to put that as a decimal. I'm going to leave it as a fraction. And then what?
Is times the denominator. So 2 over 2.
Times square root 2. We already took care. We're not even doing denominator stuff anymore. I showed that was the reason, and now I'm giving you the shortcut. So now you don't have to think about that anymore. That's it. It's a weird looking number. I get it. You've got a fraction, and you've got a square root, and you've got a, oh my god. But that's it. That's all it is. I took this number, I divided it by 2, I stuck a square root on it. Done.
That's it.
That's it. Like, don't make it more complicated than this. That's it. Cool? That was it. We're done.